Hello everyone. For this tutorial video, I'd like to explain what rational expressions are, as well as methods you can use to manipulate them algebraically. In particular, how to simplify them by factoring and by adding and subtracting. The first part, factoring, is more easier because a rational expression involves fractions or ratios, and we remember from arithmetic, addition and subtraction of fractions is more tricky than simply adding and subtracting them as is, because they need a common denominator first. So we will start with factoring first. In particular, if we remember from basic arithmetic that with a fraction of integers can be simplified by breaking the numerator and denominator into their factors, it should not hopefully be too surprising that a rational function can be done in about the same way. And we also know that common factors in the numerator and denominator cancel out, and this is true both for arithmetic numbers and algebraic expressions. So we can simplify fractions in that way. For example, 12 divided by 4 can be rewritten as 3 divided by 1, because 12 equals 4 times 3 and 4 equals 4 times 1. So the common factor of 4 goes away. We can use this explicit logic in order to simplify rational expressions. For example, this ratio may look daunting at first, because it's two quadratic expressions, but we remember we can factor both of these using the AC method, and we see x minus 4 is a common factor, so it goes away, and we conclude the simplified version is x plus 2 over x minus 5. If we have something messy like this, where the numerator and denominator do not have matching forms, we would factor the numerator, but unfortunately we cannot factor the denominator using the methods we know, so we will leave it as is. But when we factor the numerator, we can see that x to the 5th power is a common factor, so it divides by x cubed in the denominator, and x plus 1 squared is the other factor, so it divides by x plus 1 to the power of 8. We now simplify both expressions using the laws of exponents. So we subtract the exponents as appropriate, and write the exponents in the denominator instead of the numerator if they happen to be negative, which is true for the x plus 1 expression. And we conclude that is the most simplest form. We are now ready to talk about adding and subtracting fractions or ratios. In particular, we remember from arithmetic, if the denominators are different, then we have to ask ourselves, what is the smallest possible number that both denominators fit into at the same time? And this is called the least common denominator. For example, the least common denominator of 6 and 4 is 12, because it is the smallest number that 6 and 4 are both factors of. So once we figure that out, we multiply the fractions by all of the terms in the least common denominator, except for the term already existing in the numerator. For example, if we have 5/6, we would multiply everything by 2 to get it in terms of 12, and if we have 3/4, we would multiply everything by 3 to get it in terms of 12. This means we have 10/12 and 9/12, and if we are subtracting them, we get 1/12 as the final answer. So now that we have recapped how adding and subtracting fractions of different denominators works, we can move on to rational expression addition and subtraction using the same technique. For example, if we wanted to subtract these fractions, we would see the least common denominator is nothing more than a multiplication of these. So we would multiply 2 by z plus 2 and z minus 1 times z plus 1, and then we subtract them once we have it in terms of the least common denominator. We next distribute everything we can, and then simplify this distribution using the properties of addition, subtraction, and factoring. And we get our answer in our most simplest form in terms of only one fraction. Now that we have figured out how to simplify multiple cases of rational expressions, we can discuss complex and imaginary numbers next, which involve square roots of negative numbers, as opposed to square roots of positive numbers or 0, like you would normally expect. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.